Okay, this is the continuation of the earlier video. The last thing we discussed was SI units. We had 7 units here, 7 fundamental physical quantities, namely length, mass, time, electric current, thermodynamic temperature, amount of substance or matter, and luminous intensity. These are called fundamental physical quantities because these physical quantities are not derived from any other physical quantity. We will discuss derived physical quantities after this. The name of the unit of length in SI is meter and its symbol is small m. That of mass is kilogram, symbol is small kg. That of time is second, symbol is small s. That of electric current is ampere, symbol capital A. That of thermodynamic temperature is Kelvin, symbol capital K. Here ampere and Kelvin are named after scientists. The units ampere and Kelvin are named after scientists. Amount of substance, mole is a unit, symbol is small ml. Luminous intensity, candela, CD. These are fundamental physical quantities and they are units. Now we have very large number of other physical quantities which are derived from these fundamental quantities. They are called derived physical quantities. Example of derived physical quantity is speed. Speed, we know, is distance traveled upon time taken. So speed is derived from length and time, and the unit of speed will be the unit of length upon the unit of time, that is meter per second. This is a derived unit. Speed is a derived physical quantity and the unit of speed, meter per second, is a derived unit. Another example of a derived physical quantity, acceleration. What is the acceleration? It is change in velocity upon time interval or time taken. So the unit of acceleration should have the unit of change in velocity. Change in velocity will have the same unit as that of velocity. What is that? Meter per second divided by the unit of time. What is that? Meter per second squared. So meter per second squared is a derived unit. That is a derived physical quantity, acceleration, its unit. Force. You have learned force is equal to mass into acceleration. Therefore, the unit of force should be unit of mass, SI unit of mass. We are discussing SI units, okay? And the unit of acceleration. This is the SI unit of force. Now, we have to follow certain rules while representing the symbols of these SI units. Certain rules. The first rule is you have to follow the same, you have to write down, represent the units by the symbols shown earlier. The 7 symbols of the units which I had shown earlier. That is small m for meter, small kg for kilograms, small s for second, capital A, capital K, MOL, CD. These symbols are to be written as you represent a unit it has to be represented as the table given earlier. Second rule to be followed is no full stop or comma is to be used within or at the end of the symbol of a unit. No full stop or comma to be used. Example, kilogram, you should not put full stops here. This is wrong. No full stop after also. This is wrong. This is correct. No full stops to be used within or after the symbol of a unit. Is that clear? No full stop within or after. The next rule to be followed is the symbols of these units do not take the plural form. You know, singular and plural. Usually, plural we add an S after the word. 1 stone, 10 stones. We put S. Here, S should not be put after the unit symbol. That is, 1 kilogram is okay. 50 kilograms. Don't put S here, this is wrong. 50 kg without S, this is correct. So, symbols do not take the plural form. That is, you should not add S after the unit if the quantity of the unit is more than 1. Don't put that unit. Next rule to be followed is that some units are named after scientists. For example, unit of force is Newton. Newton is the name of a scientist. The unit of force is Newton. If you are representing the unit by the name, writing Newton as I have written here is wrong. If you want to write the whole name as a unit, you have to use all small letters. Or the first letter of the name has to be represented in capital. Small representing Newton by small n is wrong. So what have we learned here? If the unit is named after a scientist, example Newton, you want to write down the unit, for example 50 newtons, just writing Newton, the whole word, do not put capital, put all in small. And if you are writing the symbol of Newton, the first letter has to be written in capital, not in small. So, another example of a unit named after scientists is ampere, as I have told you earlier. Joule, which is a unit of work or energy. Joule is right. This is wrong. Representing joule, just symbol, first letter, this is wrong. Capital J, that is right. So is this rule, I hope this rule is also clear. What is that? If the unit is named after a scientist, you have to represent either, if you're writing the whole word name, use small letters throughout, or symbol, the first letter in capital. Okay. Example, another one, Kelvin, symbol capital K. Watt, which is a unit of power, or capital W. Pascal, which is a unit of pressure. It is represented by capital P and one prominent letter. First letter in capital and one prominent letter. So the rule to be followed here is, if the unit is named after a scientist, you represent the symbol, the first letter of the word name is to be written in capital, and in some cases the first letter in capital and one prominent letter in small, that is Pascal.